To measure the resistance in a resistor, first thing to do is to turn the range selector to ohms. And then check the pointer or needle fully going to 0. Just by touching the red and black probes together. If it is not, adjust the 0 ohm adjuster. Now to measure the resistance of the resistor. Let the two probes connect to each end of the resistor, and then measure the resistance value displayed on a scale. You can see here that the needle is pointing at 10. And our selector range is at times 100. So that means 10 times 100 is equal to 1K. Therefore, the resistor has 1K ohm resistance. To measure the voltage in a DC voltage, turn the range selector to DCV. Always start with the highest range of the DCV and work your way down for accuracy and to avoid damaging the multimeter. Then connect the red probe to the positive terminal, while the black probe to the negative terminal. So we have here a 9 voltage battery, and we have set our range selector to 10 DCV. When you look at the scale, the needle would be pointing between 8 and 10, which measures exactly 9 volts. With another example using 1.5 volts battery and setting the range selector to 2.5 DCV, a reading of 250 on the meter might cause confusion. Despite the scale pointing at 150, the accurate voltage remained 1.5 volts, calculated by dividing 150 by 100. To measure the current, the first thing to do is to turn off the power supply of the circuit. Then put the range selector in the appropriate current range, usually marked with A, for amperes. Break the circuit and connect the probes in the source while the other to the resistor. Turn back on the power supply to the circuit. Read the measurement based on the selected range. For this instance, it's on 250 milliamperes. If we measure 15 volts with 1K resistor, our current would be 4.9 milliamperes.